get started here. So because the first thing I'm going to do is a demo, so I will just put this page up. So the question going to be answered not by me, but by some very influential people in the community. Follow down in some other slides. But one of the things that I want to mention before I get into my demo is that when people think about Rust, people think about system programming. Think about writing operating systems. So as of today, Rust is already Linux, part of the Linux operating system. That's achievement that C++ has not achieved in the past 30 years, right? C before Rust, it was only a C that's allowed in the Linux kernel, and it is also widely used in Windows today. I think Azure CTO once said that in Microsoft Azure, there's I know we're in Google today, but that's they would start a new project all in Rust, not in C++ or in C# because it just Rust solves the overwhelming number of security issues and memory issues that are associated with systems, right? So the question people really ask is, we know Rust is great for system programming, for operating systems and such. Is it also good for application programming? Because most of the jobs and most of the use cases are in application programming. That's so for people like me, I have a lot of gray hair, so I started in Java. That's went through Ruby and Node.js, Go, and all that. That's so a lot of times you see a language get popular for different reasons. That's so if you remember why Java is popular, it was popular because before it was called Java, it was called old, right? It was write once, run anywhere. It was for devices, for browser, for writing applet in the browser. That's the name become a server because as many people start to use it, people start to discover that is a great language and there's more skill being built in the community. It will make the move to the application use case, to the new application use case the community can identify, right? So I think Rust is at that point, So I was just chatting with other guy, that's if you look at large technology companies, you can pretty much tell when it was founded by looking at the technology stack that's in the company. So if you look at, say, the Chinese tech giants, if you look at, say, Ant Financial, Alibaba, and things like that, it's all Java-based. So they are founded in the early 2000s, right? And then if you look at ByteDance and companies like those, they are all using Go. They are all founded about 10 years ago. And if you look at the new startups that's founding today, I challenge you to find one that doesn't use Rust, because Rust is the new hot thing. I think 10 years from now, we will see the giant companies using Rust, like ByteDance using Go today, right? So I'm really thrilled to I've been to a lot of Rust meetups. Also, we have just had one in Taipei, and obviously we have one in mainland China, we have one in the U.S., and I come to Singapore a lot because we have customers here. But we don't do a lot of developer events here, But it'd be really great, to be connected with like-minded Rust people here, because I truly believe within 10 years of time, you're going to see Rust everywhere, and you guys can be the pioneers, right? So before we get into some of the those slides, I want to do a demo. The demo shows you how Rust is used in the application space. So without further ado, let me start. So this is my apologies. I can't get it up to there. So so it's so the new command would appear at the bottom of the screen. Let me try to do that. Raise it a little bit higher so that you can see it. If you see this, if I do let's do what's in directory. And you see there's a bunch of files here. And there's a bunch of really large files. And by the name, you can probably recognize those. Those are the most popular application use case of today is to run large language model on your own computer, right? You run ChatGPT on your computer. But except it's not ChatGPT. It's Facebook or Meta AI's Llama 2, right? So this file is 9 gigabytes. It's a 13 billion parameter, a Llama 2 model that quantifies to 5 bits. And this is 7 billion parameter, that's the chat model. Those two are almost 5 gigabytes. And you can see this one is based on the Llama 2 but fine-tuned, so this is 5 gigabytes. So those are very large files. Those are very large, they're called large language model for a reason, right? They're large, the files are large. So they took a lot of resources to run. However, most people would run them in Python, like PyTorch. And do you know how much dependencies or memory space PyTorch takes? It's 6 to 7 gigabytes. Another 6 to 7 gigabytes, okay? So, so we're gonna get there later, but, there's, we always talk about Rust is more efficient. Does Rust help here? Can I use Rust to run this type of programs? And what I want to show you is that we can. Those WASM files are WebAssembly bytecode files, so compiled from Rust. So I write a Rust application, which I'm going to show you in a minute. It's all of them are less than 100 lines of code. And when they compile to WASM, in the unoptimized format, it's about a couple megabytes, 2 megabytes, 3 megabytes. Remember, PyTorch is 6 gigabytes, okay? So, so a very small file, the file can be copied around. I'm showing it on my local machine on a Mac, but I have another NVIDIA adjacent device, which is NVIDIA's Raspberry Pi sitting in my office. I can just FTP this file onto that device, and all the demo I will show you in a minute, and it still works there. If I have a Windows machine, if I have a Linux machine in the cloud, I just copy this file. I do not need to do the package manager and try to install stuff and and do that, right? So this is the context, so you have very large language files, which you need all the computing resources on your computer to run. Then you want a very efficient driver, you want a very efficient application that would be able to drive those files. And what I want to try to show you is Rust can fill that bill. So here I have a command, so there's the details of this command isn't that interesting, but there's a couple of things to note. Is that if you use a WASM Edge runtime to run the WASM application, so you have to install this first. It's one line command, it's a couple megabytes, and it tells the program where to find the large language model. Here, we use the 7 billion parameter large language model, and then we give it the WASM file so that it knows to use the WASM file to load the large language model. So I'm going to show you how it's written later, but I want to show you what you can do first. So here is the question. Let me ask you the question. Where is the capital of Japan? Okay, it's going to think, and the result comes back almost immediately. And if I can't emphasize enough, this doesn't require any internet connection. This runs on my local machine, on my 2-year-old Mac. When I bought this Mac, I thought I only need it for web browsing. So I deliberately chose the lowest configuration, okay? And now it runs, the 5 gigabytes language model. So the capital of Japan is Tokyo. But one of the most interesting about those large language models is that it follows conversation. So I can ask a follow-up question. What about, this is a somewhat trick question, Singapore. What about Singapore? That's because if you just ask this question, it makes no sense. What is about Singapore? It has to be asked in the context of the previous questions, right? Because I asked what's the capital of Japan, so it says, okay, Tokyo. If I say what is about Singapore, it says the capital of Singapore is Singapore, right? It knows I'm asking for the capital, right? So I can ask something even more complex. Say, is New York City the capital of the United States? Surprisingly, a lot of people actually think New York City is the capital of the US, right? And it comes back in a flash. No, the capital of the U.S. is Washington D.C., or the District of Columbia, right? So the thing that's interesting, I want to show you is that it actually runs really, really fast. It runs 30 tokens per second. So it's generating, it's actually a lot faster than human can type. So what you would feel is that the answer comes back almost almost instantly, right? That's of course, that's what I would say. If you have a properly set up Python and PyTorch, you can achieve about a similar speed, but that just takes a lot more resources. So let me give you another example. So let me quit out this conversation and restart the conversation again to show you that it doesn't just answer those kind of mundane answers everybody knows, right? So let me say, can you write a hello world program? I'll ask it to program, right? So it takes longer because it needs to generate more text, but it's also pretty fast. So it says, of course, here's a simple hello world program. As you can see, it's written in C, right? Oops, I didn't mean C, I mean Rust. Oops, I meant in Rust. Okay. So you would understand that and change that to Rust, right? So it's so now you say, okay, it sounds interesting, but that's really how much can the 7 billion parameter model do? Because ChatGPT is about 20 times more than that, and GPT-4 is a lot more than that. So then let me show you an example that I think last example in this setting. So I will ask it to write something that is non-trivial. So here is the question. I need to put on this, but I think you can hear me, right? So, write a function that determines if an input integer is prime. Okay, so essentially I will ask to write a fairly common thing that you're going to do in your program. You're going to see a lot of this type of requirements. Okay, so it gives a Python code, and it also explains it, right? So it says I would start from 2 and all the way to the square root of n, and then check every number in it to see if it can be evenly divided by n. If it is, I'm going to return it's not a prime. If none of them can be divided, I'm going to return prime. It's true, it's prime, right? So it has some optimization in here because it knows you don't have to check all the way to n. You just need to check to the square root of n, because if there's no factor under the square root of n, it cannot have a factor above square root of n, right? So it's pretty good. So honestly, guys, this is the kind of code that most people are gonna write. This is the kind of code that is fairly common, right? I would say a lot of developers who give us PRs in our community write code like this. It's fairly straightforward and it's good. However, it's not really really optimized, because you can see I can ask the follow-up question, but why do you check even numbers over and over, right? So you really don't need to check every single number from 2 to the square root of n. You just need to check the odd numbers, because even numbers we already knew it wouldn't be, did it? It's the same thing. Okay, well, that's, so, well, the large language model sometimes, you can't predict what it's going to do. So it says you are correct, check even number, which is not necessary. So the updated version gave the same thing, which is wrong, right? So well, sorry, the demo has not worked as advertised, but the notion I want to say is that we had a large language model connected to our GitHub repository. We ask large language model to review all the PRs that the community submitted to us. And this is a real world use case. Someone sending a JavaScript a function is called isPrime, and that's how they implement that. And the large language model gives review comments. It just has one sentence. You don't have to check your numbers again, right? That's it's really revealing to me. That's it is a thinking level that is in my opinion, it is above a lot of developers. But anyway, that's I encourage you to. I'm going to show you, with perhaps within 5 minutes, you will be able to run this thing and have the same experiment right there on your own computer as well. But so let's go back to the slide. Before we go back to the slide, let's have a look at the source code of this program. Okay, so you say you did a Rust, it's only 2 megabytes, but how big it is? That's the entire application. Okay, it's 66 lines of code with all the comments, all the blank lines, and stuff like that. And I can actually go over them with you really fast. So here's a read input, which is just when you see the question, it is a loop. So it takes the user input. It's people say Rust is difficult, but do you really think that's difficult? That's I'm sure. If you have no Rust background, you would be able to find this is not very easy, right? Then you have the main function. The main function takes 2 parameters. The first, only takes 1 parameter. Well, it's the first parameter is the model name. So where do you find the model? So then set up the system. That's to load the model, and the execution target is auto, which is interesting because it allows the system to automatically detect what hardware you have on the system. So on the Mac, it's the reason we can achieve 30 tokens per second.
Can you zoom the code?
Oh, zoom in? Okay. Okay. Wow. Okay. Maybe too much. Oh, okay. Thanks. So the auto is what allows you to do the portability. That's I just mentioned the 2 megabytes volume file can be copied onto any device on the operating system. Windows machine, Windows machine with WSL, but a Linux machine definitely, any Linux machine, and with or without NVIDIA GPU, and the Mac machine with or without the neural engine. The fact it can run 30 tokens per second, which I believe is the state of art at this moment. That's the fastest you can run on this type of hardware. It's because it automatically detects the GPU or the neural engine. That's the M1 or M2 processor it uses, right? So it loads the model and builds the context. And then I did a little thing which is not strictly necessary, but it improves user experience, is I give it a system prompt and then ask the initial question. The reason to do that is to make the response to the first question faster, right? Because then, or why ask where is the capital of Japan? It has already loaded the model. The first question has been asked, right? The model is already in the memory. So in this step, forces the model in the memory. But I think this is somewhat a hack that we can still optimize that. When we optimize that, the total program is going to be only 60 lines of code. So then we took in a loop. That's ask a question, and when people give the question, there's something called the Llama chat template, meaning that the question and answer has to be fit into a specific format, so that the model recognizes it's a conversation, right? So that's where it is. So INST is a short for instruction, right? So all the user input are put in the square bracket of INST as user instruction. Then here's the important part. You just turn the whole user the user questions into a tensor and pass it to the runtime engine. Here, so we use the GGML runtime engine and then compute, and then we get the result and display. That's it. that's all there is for the Rust application that can do, I think, fairly, I think this is a simple application. I think you will have to agree as well. This is a simple application. Someone who has no Rust background would be able to understand it. And you will be able to do the state-of-art AI inference that is currently possible, the fastest possible on a variety of different hardwares. And on your own computers, that's by just compiling this to WASM and run on your own devices, right? So this is, I know this is a long demo, but I think it's important to to have those so that it establishes the notion that WASM is Rust is not only good for system programming, but also for application programming. What type of application programming? And you can say the most advanced and most popular type of application programming, like AI inference today, can be easily handled by Rust. So let me go back to my slide. So the rest of the slide can go faster, right? So here's our demo. That's come on. Okay. So this is a DIY. So that's the code I mentioned. And in order to replicate everything I have just shown you, it actually took a slightly different model because the Llama 2 7B model has some copyright issues. You have to sign up for Facebook and agree to their terms and what have you in order to use that. So Mistral is one of the models that fine-tuned based on Llama 2, which is it actually answers the coding questions very well. You can ask them, you can ask it to teach you Rust. It would be, that's so the challenge for you is to take the Rust examples from the Google book, right? The comprehensive Rust, and ask ask the model to explain it to you to see if it can correct it, right? So it's only 4 lines, 4 commands. The first is to install WASM Edge. You can install it, I think, in most computers within 15 seconds. It's going to run and download something and install. And then you download that WASM file. That WASM file, like I said, it's written in Rust, but already compiled with WASM, and so it's cross-platform compatible. Regardless which machine you are, or what kind of operating system, or what type of CPU you have, you can just download that file, and it's going to run. And then download the model. Downloading the model takes some time. It's a 5 gigabytes file. And then you use the command I've just shown you to run the model, and then you can start, asking questions and getting answers. So that is the whole thing. So let's come back from the demo and go back to some high level stuff. So people, when I do things like that, when I do a demo like that, the first question people ask is, why don't you just use Python? Because isn't Python a lot easier? Python certainly is a very popular language and is largely driven by data analytics and machine learning. If you see today, the number is from July 2023. Python is the most popular language. I think it's far more. Actually, it's actually quite a bit more popular than Java. So it's kind of surprising. So it's we have to answer the question, why not use Python, right? So I think the answer is multidimensional, and this is one of the best illustrations of famous people saying why do they not like Python, right? So Chris Lattner, I think many of you might know him. All know of him. He's the inventor of the LLVM, and he also invented the Swift programming language, which is the predominant programming language for iOS. And so he's a very accomplished computer scientist in the world of compilers, performance, and all that. So he recently started a company called Modular, and they created a new platform, a new programming language called Modular. And I took this screenshot because if I say this, nobody would believe that, but because Chris said this, so you have to believe him, right? That's Python compared with, say, a compiler language like C++ or Rust. The performance difference is not 30% or even 30 times. It's 35,000 times, okay? So if you are writing application, you have, as we will see later, you have to be really careful not to put your an important logic in Python. Okay, all the important logic has to have corresponding underlying C libraries. If you inadvertently put anything important in Python, you would have a huge performance hit that is really hard to debug. Because Python is 6 orders of magnitude slower than anything that's than anything else that's on your machine, right? So that's a very compelling argument against using Python. Is that Python is easy for sure, but say if you are doing something that's, say you are preparing the tensor and you need to do some computation, and you invert you chose a Python implementation that is easy to find and doesn't have external dependency, so you thought it's great. But you are likely to pay a very high price in terms of performance, right? So Greg Brockman is the president of OpenAI, and this is what he says. So much of the modern machine learning engineering is not make Python not to be a bottleneck, is to really understand where Python fails and how would you fix that, right? So that's that notion Python is slow is actually I think well established in the academic field. So this paper came out in 2020. I remember at the time, in the middle of the pandemic, I was sitting at home with nothing to do, so I was reading those academic journals. This paper is published in Science, right? So it's one of the most prestigious academic journal. And the title is very interesting. The title says, "There's plenty of room at the top." Okay, so because why did it? By the way, a lot of the scientists that co-authored this paper worked at Google. Why did it say there's plenty of room at the top? It's because 40 years ago, there's another influential paper with the title, "There's plenty of room at the bottom." Okay, so in that 40 years ago, that paper argued that software is not that important, or performance in software is not that important, because there's huge room of improvements in the bottom of the stack, which is the semiconductors. So if you can improve the chips by factor of 10, it can afford a lot of crappy software that you write. So the optimization of software is not that important. The optimization of hardware is far more important, right? So who's the author of the article? There's plenty of room at the bottom. The name of the author is Gordon Moore. So that paper established something called the Moore's law, right? That drives 40 years of advance in computer science. Is that the hardware keep improving, so the software can get ever more sophisticated. So you have beasts like Python, right? That's it looks okay, but underlying it runs very slowly, right? So fast forward today, it is the computer is acting up. So fast forward today, it becomes I think you can turn on lights again. Maybe I should unplug and replug. Oh, cool, yeah. So 40 years later, I think we are at the stage where nobody is talking about Moore's law anymore, because we are not seeing the CPU improving double every 18 months. The Apple come out with a new CPU that is 30% faster than things that we released last year, and we all thought they are so great, right? So it's so Moore's law is not there anymore. So the title of this article, "There's plenty of room at the top. What would happen after Moore's law?" The answer is really there's Moore's law in the software. By having a new software stack, that is, so, there's a comparison, right? So the comparison is actually even more dramatic than what Chris Ladner has said. If you look at Python and Java, if you look at languages like that, with hardware optimized C++ and Rust, you see a huge performance difference. It's 5 or 6 orders of magnitude, right? So, if we consider the improvement we can squeeze from software by replacing those heavyweight stack, there's we can have another 40 years of good times in terms of computer engineering, right? It just we can't squeeze from the bottom anymore. We can squeeze from the top, right? So so that's I thought that was a very interesting and also influential paper. And also, if you see the things like AVX, that's you might remember in my demo that I have when I logged the information about hardware, it has AVX2, AVX515, things like that. Those are CPU optimizations that allow CPU to do parallel processing, right? It's also called CMD. And so there's a lot of those things that can be readily taken advantage of by things like Rust and C++, but really hard, if you have just the pure Python or Java, things like that. So, I think this is perhaps, a bigger picture view of why we think Rust is on the cusp of, taking over a lot of things, because it's highly efficient. That is because the Moore's law is not there anymore. You can't squeeze more performance from hardware. So you have to squeeze performance from software. Where does the performance software come from? It comes from new languages that's both modern and also high performance, right? So of course you can do C++, but people don't like it. So so you definitely would choose a more modern language that has modern features like Rust, right? So this. So going back to Python, and another really big myth is Python is easy to use. It may be true maybe 10 years ago, but but if you try to install anything sophisticated on Python, it becomes really, really hard today. That's so you would find, say, there's a famous tweet about two very famous packages that has directly contradiction dependencies, so you can't install them at the same time. One is a web service, the other is a large language model inference, right? So if you don't know those guys, Chris Alban is the CTO of Wikipedia. Okay, so that's so he's saying that's what's the right way to install Python? I dare not install Python on my Mac. That's why we use Wasm and we use Rust to run those large language models, because I know if I try to install PyTorch and all the drivers that are required for the Mac, it is in all likelihood it's going to mess up my machine, and I would have to wipe it and reinstall it, right? So that's that's installing Python and pip has become a scary thing for a lot of people now. That's so I would argue Python isn't really that easy to use, and if you consider the development machine and deployment machine are probably different, that you would have even bigger problem, because the things that you run well on the development machine may not run at all on the deployment machine, or they may appear to run, but they don't use the hardware correctly. So you're going to get orders of magnitude slower performance as well. Anyway, so Python has huge dependencies. It's a very expensive wrapper for C, because all the underlying libraries of Python are in C, so it's gigabytes upon gigabytes of dependencies that you have to manage really carefully. So that answers the question, what is the language of AGI? It's definitely not, I didn't say it's Rust. He said that, okay? Him, okay? So the guy asked, AGI would be built in Python, let that sink in, he says, how depressing, that's the most important thing human gonna build is gonna be built in Python, right? And this guy says, no, it's not. It's going to be Rust, and he did not really provide any of the reasons, and I filled in the gap for him, right? That's because of the expiration of the Moore's law, the requirement for performance, the requirements for developer friendliness, the requirements for the lightweightness. One of the things, because we deal with a lot of people who use Rust in the application space. We see a lot of use cases, say in the US and in China. One of our customers has been running Python inside the Docker in the car. Okay, so they have autonomous driving system in the electric vehicle in the car, and they are using Docker plus Python to run it. That's it takes enormous amount of computing resources in the car, but that's essentially how the I would say computer science, the people who work in algorithms think, that's because they develop the algorithm in Python. So they automatically think we must run it in Python, but it's not. That's I think most sophisticated big companies do not do it in that way. You see a lot of startups do that. So because of that, there's a whole generation of new frameworks or approaches that are what we call zero Python dependency, right? So one of the most interesting one, which is also where we build our demo upon, that we build a bottom edge as on top of llama.c++, right? So this project, I want to show you an interesting graph, So the red one, those are GitHub stars, basically the proxy measure. It's not a great measure, but it's a proxy measure of the popularity of the project in the community, right? So the red line is PyTorch, okay? You can argue it's probably the most successful Python frameworks of all times. That's because it's replacing TensorFlow. That's since 2016, right? From 2000, it's pretty much a linear growth curve. And if you look at llama.cpp, the chief selling point of this one is zero Python. Okay, so you can see the growth of those things are pretty much not on the same, for lack of better word, not on the same spectrum. One, if you think this is linear, the other one is pretty much exponential. So there's other zero Python inference libraries. A lot of those are around large language models because that's what's hot today. That's where people want to spend their time, right? So this is coming from the OpenAI, and they wrote a C-based library, not C++ based library, but a C-based library to do llama inference, right? And then there's Whisper C++. This is also OpenAI. We know their better name is called closed AI, because a lot of their stuff is just closed, right? But they do have some open source models, like Whisper is open source model. It's one of their audio and voice recognition software, and so people have built inference libraries around that as well. It's called Whisper C++. And also interesting, and I think a lot of people in the Rust community are very excited. It's a Hugging-Face project called Candle, and it is also quite popular now. It is a native Rust application that you can build that does AI inference, for large language models. The reason we are not using that at this moment is because it's still not as mature as say the llama.cpp. That's because we ask people to write application in Rust, but then run it in the WebAssembly engine. So our WebAssembly engine embeds AI inference runtime, right? So Candle is a project. If you're into Rust, it's definitely I'd encourage you to check it out. So we have talked a lot about I hate to do that. I hate to say which language is not good. Because tends to get people into really passionate debates. Right? That's I've said enough bad things about Python, but I don't really think Python is bad. I just think it's bad for AI inference. Right? It's if I do model training and even if I do data manipulation and all that, or just I personally use Python a lot. I just don't use it for model inference, which I think it's the wrong tool, right? So that's. Like I said, Python is a C framework. In the context of AI, it definitely is the case. Like I said in the beginning of the talk, much of the work the Python developers has to figure out is how to use C as much as possible in your Python program, how to avoid pure Python. Because as soon as you get to pure Python, you are 35,000 times slower than almost anything else out there, right? So with Rust and Wasm, compared with Python, so the first, I think it's rather paradoxically, it's just a simplicity. That's people who haven't used Python for a while tends to remember Python as a simple as a simple language and with a simple runtime, but it's not the case anymore. So with Rust compared to Wasm, you can have self-contained binary app. There's no dependencies. There's not only no complex dependencies, there's no dependencies, right? You just copy that single file. You copy it across different devices. That's the original promise of Java, right? Java says, want to write once, run anywhere. It was never realized, but it's being realized in Wasm, interestingly, almost 30 years later. Right? It's 1,003 orders of magnitude smaller, 5 orders of magnitude faster, right? That's compared with Python. But it's also, the other interesting thing is, if you just look at the performance and all that, then you can use C++. Why don't you use C++? People, but that's the other interesting observation that I have, is that whenever there's C++ today, there's opportunity for Rust, because Rust is really designed to replace that. That's happening in Microsoft, that's happening in a lot of places. So with C++, or with regular Rust, you would only compile to a native application. The native application is unsuitable for cloud deployment, because if you want to deploy a native application in the cloud, you have to have a container around it, right? So a VM on container, which adds to a lot of weight, adds to a lot of complexity. So it's not so with Rust and Wasm, because our we are the first one. Wasm Managed last year was the first one to collaborate with Docker. So to make the Wasm runtime the first class citizen in Docker and the Kubernetes ecosystem, so that Docker can start a container or start a Wasm runtime. So there's a lot of people are using Wasm this way, right? As a container format. So it's a cross-platform binary, because Docker has never been a cross-platform binary. If you want to use Docker on NVIDIA devices, you have to use the NVIDIA Docker. If you want to use Docker on ARM devices, the Docker image for ARM device and Docker image for x86 device are different. So you at runtime at the management level, you have to choose. Depending on which hardware you have to choose the different runtimes and adding all kinds of complexities, right? But I think also very important with things like Wasm, you can have modern languages like Rust, and so that's the reason to use Wasm. This is I think I pretty much covered that. Because in our view, I know this is a Rust meetup, but in our view, Rust and WebAssembly are two very closely tied together technologies. They are both developed in Mozilla Labs about 10 years ago, and they are often used together. It's so much so, I would say that Wasm has become for a lot of people, at least for us, Wasm has become the default compiling target for Rust. So, the Rust Foundation doesn't sponsor a lot of projects, doesn't organize a lot of events, and the only events it organized last quarter was WasmCon event in Seattle. So we went to so CNCF and Linux Foundation has a WebAssembly event in Seattle last month. It's called WebAssembly Conference, right? And Rust Foundation had their official events there, the day before that. It's called talk about Rust and Wasm, how to compile Rust into Wasm. A part of the reason is driven by those findings. This is the CNCF annual survey of last year, so it happens, the survey took place about, the result came out early this year, right? So I surveyed a couple thousand developers and also IT managers that are members of the CNCF and Linux Foundation. So there's the key findings, the most important takeaway from the survey. There's only one key finding, although said key findings, but there's only one. It's summarized to this sentence: containers are the normal. We have won the container war. Okay, we don't need the virtual machine anymore, or we don't have to use the virtual machine anymore. So the CNCF, their founding mission has been realized. Right? And the second part is WebAssembly is the future. Right? So you would see that's in the cloud native environment, people who runs large cloud and large servers, they see WebAssembly as the container format of the future because it's much lighter and much faster. It doesn't have the cold start problem. It can run at much higher computing density. So let's think about the Docker container. Why we are against running the Docker container plus Python in the car? Not only because Python is slow, but because of Docker. There's, I think at most 4 Docker containers for each CPU core. Okay, but if you are running WebAssembly, you can have thousands of WebAssembly instances for each CPU core. You can organize them in green threads or in coroutines, right? So there's lots of benefits that you can squeeze. It's the same logic that I've talked about before. The hardware stopped improving, so you have to squeeze more performance from software, right? So WebAssembly replacing container is the same logic. So it's and how do you get a WebAssembly application? Is by using Rust, right? So far, if you want to develop a WebAssembly application, Rust is by far the easiest and the best supported language out there. So, I know I'm dragging a little long, so I would go faster in the next couple of slides. So what I want to show you is that, I'm showing you how to use Rust and Wasm to write very compelling large language model applications. You can do it, you can do it with, I think within 5 minutes on your own computer, right here. Before you leave this room, you're gonna have a private chat agent sitting on your computer that can talk with you. But there's more. It can do more than just a large language model. So this is a project our open source community has contributed. I think this is one of the it was done by a graduate student in China, and it's one of the Linux Foundation internships. We have 3 Linux we have about 12 Linux Foundation interns every year working on our project, working on Wasm Edge, and they are paid by Linux Foundation. So so they are, I think they are pretty competitively compensated. And I would really encourage students or a young professional in Singapore to apply this as well, because most of our interns in the past has come from India and China and also Taiwan, but none of them has come from Singapore. So we would love to see more participation here as well. But this is one of our students. He's a graduate student in China, and so he basically took a very popular AI model library from the Google Cloud. It's called the Meetup. So Google Cloud provides this as a model as a service, right? So you can APIs, you can call those models. It's so they selected a lot of very popular and high performance models to do things like object detection, image classification, things like that. All those coming from Google, all those models are TensorFlow-like. Okay, so so for our application, this is the entire application to do the image, to do the object detection model. So as you can see, it's it's similar to how we do with the large language models, isn't it? You have the context, you load the model, the model is a file, it's just in the large language model, it's a 5 gigabytes file. This one is maybe 100 megabytes. You load the file, load into the context, and then you feed the data into it to say compute, and then you get the result, right? So you can read this. This is I would say pretty simple Rust code. That's even someone without Rust background should be able to read it, right? And the model I get is the model I use is the model direct from Google, but then I feed this picture to it, right? I just read this picture into memory and feed that into the model. And so what the result what I want to get is that after it does its computation work, it's going to get a struct called detection result. I'm going to print that result as text, and then I'm going to have another helper function to draw that into the original image, right? So you can see this is the result, right? So it's it prints out the coordinates of the object detected from from the image, and then will give you the name of the object and the probability of the object. So so it knows for 84% certainty this is a cat, for 83% this is a dog, right? So as you can see, for things like that, if you have a stream of data like a video, that you will be able to run things. If you can run those things fast enough, you can do a lot of those. I'm sure you have seen that famous video where there's a surveillance camera in a Starbucks, right? That's everyone in it is labeled, so it knows who's sitting there on their laptop for hours without ordering drinks, and who's ordered a lot of drinks, and for the workers who have filled more orders than others. So it's very it's very. I mean, it's but in some ways it's a great use case, but it's people take it very negatively. But it's a stream of video that if you can analyze that in for like 10 frames per second, you'll be able to label and analyze those videos very efficiently, right? So that is one of the I think the great use cases, because if you have a heavyweight framework that takes even a little bit slower, you may not be able to handle videos in that efficiency, right? So, and then there's okay. So this is large language model example that I've just shown. So today, by using Rust and then compile to WebAssembly, you can have direct access to those models. I have shown you the large language model, which we use GGML. I haven't shown you PyTorch, which we can also use, and we have I have shown you that we can do TensorFlow, because all the Google models are from TensorFlow, and we can also do OpenWino, which is a format that Intel has, right? And there's a lot of C-based frameworks that make Python fast, right? So like the OpenCV and FFmpeg, Python uses those programs very extensively by building Python-based wrappers around those type of C libraries. And we do the same. With Rust and WebAssembly, we have the Rust API to access the OpenCV so that you can operate the camera and you can operate a video stream and things like that. And then So there's a lot of interesting things going on. There's also a lot of work. That's because the Python ecosystem was built out in about 20-25 years, and the Rust machine learning ecosystem was just started. I think I would say after the pandemic. So it's like 1 or 2 years old, right? So it's still in the stage where there's a lot of work that has to be done. And if you are interested in contributing to open source, I think this would be a great opportunity, because you don't really want to contribute to a very mature project, because there's very little you can do, and it takes a really long time to make a meaningful impact. But for something that is emerging, for something that is just coming up, it's be a lot easier to make a big impact. Yeah. So so there's many supported library. But anyway, so that's is it okay? So I think that's really all I want to say about this whole thing. That's why you use Rust, and why do you compile to WebAssembly? How does it compare with existing solutions? I'm not claiming it can do anything that existing solution cannot do. We're just saying it's going to be better, and we also make the argument why doing better is more important than ever, because of the Moore's law is not here, so you can't rely on hardware to get better anymore. Have to do the software to get better, right? So along that line, we not only build the AI inference application in Rust, we also build a whole AI agent in Rust. It's also open source, and you can go find the. So this is a preview. We are going to launch this with the Rust Foundation, perhaps I think in next month at KubeCon in Chicago. So. What it does, it's a pure Rust application. It's a Rust application that has a AI, a large language model at the backend. But the application also has ingested a large amount of Rust knowledge from the book and from the examples from the Rust Foundation. And then we tuned it so that it would answer Rust-related programming questions very well. So it is listed in 3 forms. There's a web form if you just open that web page. If there's a Telegram form, if you add this bot on Telegram, or there's a Discord. If you want to use Discord, you can join this Discord server and try to chat with them. So currently it uses a variety of different backends. So the Discord one probably behaves the best because it uses GPT-4. But we are trying, but we are getting one of the llama models trained on Rust material so that it can be, it can at least for those type of questions, hopefully outperform the OpenAI's closed models, right? So, but the things I want to emphasize is that all those are open source. The software, the source code on how to build it, how to deploy it, and it's all written in Rust. It's all open source, and you can. Now we have finally come full circle. You can use Rust to learn Rust, right? You can use, you can learn Rust using a Rust-based, learning system like this, and using large language model trained with Rust content, right? So I think this is the opportunity that's a previous generation of developers has never had, right? So I hope, I really hope it would accelerate the learning and adoption of the Rust language. So yeah, that's sorry I dragged too long, and thank you very much.
So if anyone wants to ask a question, you can do it because we also have a T-shirt provided for anyone who asks questions, and there are free stickers over there. If anyone of you guys would like to have some of these stickers, I will show you. You can pass it on. If you like it. There are more over there. Yeah. So, any questions? Yeah.
So I want to ask, how do you think about using Rust in GPU programming? Do you think that it has potential to replace CUDA for other programming or become a supported language in CUDA?
Yeah. Like this? Okay. Yeah. So I think CUDA is a very special case, because it's very tied to the media architecture, and it's not open source, right? So currently the role Rust has played is the one that I demonstrated. So the Rust application, if you copy it to a machine with a CUDA toolkit and the media GPU, it would run on the media GPU without problem. That's so you're gonna see a dramatic performance increase over CPU. So the way Rust is used today is to interface with CUDA, right? So the CUDA stuff, actually on the Mac it's the same. Mac has a Metal framework, where you have to write in their language. Yes.
I do know something about that too, but it's not me, but there's a developer that uses Rust.
Yeah.
There's a developer that uses Rust on the GPU, but it's on the Mac M1 GPU.
Okay. So which team is that? Apple? No.
No, she is own developer. It's a developer for, if you know the project Asahi Linux.
Okay. Yeah. So
they managed. I think the developer loves to use Rust, and she managed to. I don't know if it uses Rust or not, but it's something about being able to run sort of like render objects using the GPU, because they weren't able to do it before. Now the Asahi Linux can be able to implement the GPU.
Right. So so there's open source stuff. If GPU is open source, then you can do it. I think the NVIDIA GPU.
It's reverse engineered because it's the M1 Mac GPU.
Right. Okay. So as you can see, our Rust application can also use the M1, right? But it's through the Metal API integration. So I agree with you. There's a movement to have Rust directly using the GPU, but on the GPU side, we don't have a framework called LLVM. On the CPU side, we have LLVM. That's why Chris Antner's work are so important, because he created LLVM. That's the middle tier that allows any language to compile to different CPUs, right? On GPU, we don't have that yet. because a lot of GPU makers are not cooperating with those type of initiatives, right? So I think it'd be harder, but if you consider Rust as a system language at that level, it should be able to access GPU. In fact, if you look at Hugging Face Candle, it can access GPU. But I think it's the same way. That's how we access it. It's through the CUDA SDK and through the Metal SDK. So through the interface, the hardware manufacturer has exposed.
So what are some Rust libraries you recommend for actually implementing like model architecture in Rust?
So it really depends on what type of application you want to do, right? So what model architecture? So for instance, the PyTorch, right? There's the PyTorch library itself is written in C. But there's a Rust SFI for it, right? There's called Torch RS. And you can also use, the framework that we use is WASI. In WebAssembly and WASI, it's less optimal for training, because it doesn't provide a rich set of functions. However, it's really great for inference, because inference there's only two functions. It just sends the tensor to the runtime and get the tensor back, right? But in order to do the training, that's one of the things that I think the community is still trying to figure out. How much a role Rust can play in training, because in training you need a lot of interactions. So Python is really good for that. That's because you can see the charts and then you can go back and change something and immediately change and things like that. But Rust requires you to compile and things like that. So Rust is good for production applications or inference applications where you compile it once and you run it a billion times, instead of you compile it once and you only run it once and then you have to recompile it again, right? So that type of thing is a natural fit for scripting languages. But there's lots of talk about a scripting layer on top of Rust. So it's the Rust ecosystem has a lot of great innovations that you can that's I would really encourage you guys to look up.
Hello. So I actually want to get into the field of data science. So I just wanted to understand, is Rust really important for data science? Does it play a big role in data science?
I think it's going to, so I'm not going to lie to you, if you are getting into data science today, the vast majority of work you're going to find is Python, Python has pretty much beat out R or any other languages out there, right? However, like I said earlier, if this is the scientist work, it's the scripting language is better, because scripting language allows you to iterate and change and all that. But if the work is engineering, if you want to do applications on top of it, then I think at least at this moment, Rust would be a much better option. And I suspect that in a couple of years, Rust would be a great language for the training and for scientist work as well, because the tool chain can be more built up. So.
Thank you.
Like you showed that like the benefits of like compiling the inference code into WASM, such as you can run it anywhere, but WASM can be compiled from like many different languages. So like why should we choose Rust instead of like C++, for example?
Yes. So the original idea, or I think it's still perfect. WASM is what they call polyglot, meaning that's it supports multiple front-end languages. However, not all things are created equal. So far Rust has the best support. The relationship between Rust and WASM is almost like Java and JVM. You can run JVM without language. You can run Scala. You can run a lot of languages on the JVM. But Java is always the most native and the best, right? Because most people work in that area. That's where I think it helps the WebAssembly team or most people in the community share the same roots as the Rust people, because they all come from Mozilla. So they used to work together, right? So it's one of the I think community thing, right? But we love now there's more, we say scripting language that be made available in WebAssembly. So for instance, Google has written, I think, big announcement, but maybe not so huge for you guys, is to make Go directly compile to WebAssembly, because the regular Go really, in the past, has difficulty compiling to WebAssembly, so they have to use tiny Go and things like that. But in the past couple of months, Google has made an announcement, so Go will become first class in the WebAssembly as well. But it's still, I'm wearing my Rust hat. I would still argue that the source code written in Rust and compiled WebAssembly is probably going to have the most efficiency, where it's the most important thing. That's a feature that we can get from Rust.
Thank you.
Yeah. I was just looking at the Rust project. Like, I was surprised to see it's implemented in C++. Is it like just a historical thing, or?
You mean Wasm Edge is written in C++, right? Yeah. So we get this question a lot. That's because there are several. Wasm is a standard, so there's multiple ways to implement Wasm. So there's one way to do it. So there's projects that's implemented in Rust, right? Like Wasm type. However, if you look at V8, which is another very popular Wasm runtime, it's written in C++ too, right? So I think that there's underlying language choice that you make when you set the goals for your runtime. So for instance, we are called Wasm Edge. Why do we call ourselves Wasm Edge? Because we want to run it on a lot of edge devices. A lot of those devices, when they come out of Taiwan, they have C++ support first, right? The drivers are written in C. So that's where the choice that we make. Yeah.
I heard you mention before to building a scripting layer on top of first, but what would be the advantage of that? I suspect it would be faster to compile it, but it's also just having scripting. So. Yeah.
So the question is, what's the benefit of having a scripting layer on top of Rust? Because that defeats a lot of the benefits that Rust offers, right? I think it's everything happens in a spectrum. Having a scripting layer at the very least, it makes Rust a lot easier to learn. Because you can have a web-based console and people would just like Basic or like Python would just have an interactive shell that they can interact with it. That's so there's lots of benefit in make it easier to start, and also to make it more interactive, right? Does it make Rust compile faster? That's one of the areas a lot of people are working on. So I think in the past couple of days, there was a new feature, parallel compiling for Rust, right? There's you would be able to utilize multiple CPUs. The compiling speed was increased by 30%. What have you? So I think there's a lot of things that's happening in the Rust community that would allow the trade-off between produce highly efficient code and properly checked safety code versus a lightweight check, something like that. That would give the feel of Rust, but compile faster and more interactive. So it's but all those are, I would say, fairly open questions, because people have also talked about making the Rust macro system into its own domain-specific languages for different things. People are talking about, because the Rust macro system is itself Turing complete, so you can develop a whole language based on that, right? Based on annotations and all. So would that happen? That's people. I mean, this is benefits of having a large open source community. There's all kinds of crazy ideas. It depends on whether you want to spend time with that or not. So it does depend on that.
Okay, we'll have one last question. Maybe one or two, I guess.
Thank you for the presentation. I love it a lot. One of the questions, two questions, if I can ask. The first one is that when you do the demo for the product, like Llama.c, right? What was the hardware that you saw running on to get the state of, let's say, 30 tokens per second, if I'm not wrong, right? So that's very amazing, because trying to run it on very advanced GPU and cannot even get there with them. And the second question is, let's say we now move that to production server cloud, right, to the cloud space. That's where WASM Edge shine the most. Let's say if you call it to, I don't know, let's just call out just a normal EC2 instance, right? How many vCPU would you probably even need to reach that level, or is that even possible at all with vCPU?
That's a great question. So I'm running it on this laptop. So I bought this laptop this is a 2-year-old laptop, and when I bought it, it's I bought the cheapest available 16-inch because I need a large screen. M1. So so it's in today's standard, it's fairly low end Apple hardware. You have to say. So yeah, I agree with you. 30 tokens per second is really quite amazing. However, if you just have the CPU, you will not get there. If you just have the CPU, even the state-of-the CPU, you're gonna get 1 token per second at most. That's so it's gonna be very slow. However, on the EC2, there's lots of GPU instances. That's where they have the A10, I believe. That's so even with a small GPU, that would make a dramatic difference. That's that's where you say, that's, I know where the hardware innovation is coming from. It's not to get those things faster, it's to get more of those things, specialized things. So if you get, say, because, I want to give you what Google Cloud has, but I don't know it's from top of my mind, but, it's on the AWS Cloud, there's a certain series of instances that are, that are GPU. And you don't need to get those high end, that's really hard to get, like A100 or H100. You only need to get those ones, like I said, A10. That would be sufficient for a large variety of models, and you can run it really fast.
Okay, I guess that's it. If you guys have more questions, you can always reach Michael. He will be here until the end. And don't forget to check out the Learn Rust bot if you guys are learning Rust. And next up, our speaker, Alan, will talk about KWASM on GKE. He will give a demo.
Let me